This is Benjamin Chesser again. Thanks for joining us, or me, I guess. I'm alone. And this is going to be period 3 overview. The main theme is going to be the Renaissance, and this is taking place from the 14th to the 17th centuries in Europe. A major boost in the scientific discoveries and the developments of this time was rediscovering and retranslating ancient Greek and Roman literature and scientific works. Progress during the Renaissance began in Italy, which we'll discuss in a second. And also major developments increased the efficiency in trade, which increased wealth, which again increased the scientific discoveries, because you can't have a lot of scientific discoveries if you can't afford to allow for an intellectual class to exist. So the first people we will look at are the Italian abbesses. So Italy was the ground zero for the Renaissance because it was the wealthiest. Italy was flourishing during the 14th century due to their industrialized city-states and also trade. Cities like Florence produced cloth, Milan produced firearms, and also Venice and Genoa were essential for trade. They had very good seaports, and they did extensive trade with the Ottoman Empire, among other places. This again added to their wealth, and thus they could afford to make advances in the sciences and really focus on that instead of just surviving in agriculture and such. So their again, getting into a little bit of math, their major focus and dependence on Islamic algebra, which benefited efficiency in trade. It benefited trade because instead of relying on the old merchants relying on the old system, which would necessitate them in keeping account ledgers, would necessitate them for carrying with them a counting board, a bag of counters. The new method would only require them to use pen and paper. So they were essential for teaching and spreading the Hindu-Arabic decimal place value system and algorithms for using it, which helped their trade immensely. So they were similar to previous mathematicians initially during the 14th century in that they described their mathematics in words. However, we see a shift away from that approach, describing mathematics in words, by the end of the 15th century. Not completely. We'll see kind of a progression of mathematicians using less and less words and more abbreviations and symbols as we go on. Major development in mathematics during this time was the extension of Islamic quadratic equation solving techniques applied to higher degree equations. Major mathematicians include Maestro Dardi of Pisa, Luca Pacioli, and Paolo Gherardi. And Maestro Dardi of Pisa did major work in that area of applying the Islamic quadratic solving techniques applied to higher degree equations. So he took Al-Khwarizmi's list of 6 linear and quadratic equations solved from 6 to 198 equations. And Al-Khwarizmi only did up until degree 2 with his 6 equations. Maestro Dardi of Pisa did up to degree 4. Luca Pacioli introduced abbreviations for plus and minus. Paolo Gherardi, in his Libro di Ragioni, 1328, introduced rules for adding fractions with different denominators. So next category is going to be Northern Europe. Was not a very pleasant time to live in Northern Europe. As we'll see, the 17th century wasn't much better either. But this time wasn't the greatest because Black Death in 1347 Oh, and again, Northern Europe includes France, Germany, England, and Portugal. So it wasn't the greatest time to live because the Black Death in 1347 estimated to have killed around 50 million people, somewhat worse than COVID-19, I think. Thank God. The 100 Years' War between France and England. And the 16th century was defined by expansion and colonization. Spain leading the charge in this. They found and brought back huge amounts of gold and silver from Mexico at the time. Christopher Columbus making his voyages across the Atlantic Ocean in the late 15th and early 16th centuries. See the first glimpses of capitalism during this time. So a lot of stuff going on during these centuries. So mathematics-wise, we'll look at this guy's Nicolas Chuquet's work, Triparty. So Nicolas Chuquet was a French physician and mathematician, known for his work Triparty. And we'll just look at the three parts of this work to get an idea of the mathematics taking place at this time. So in Chuquet's first part of his work, Triparty, it concerned arithmetic, used the Hindu-Arabic place value system, and also explained basic operations of equations with whole numbers and fractions. Second part dealt with the calculation of square roots of numbers that are not perfect squares, and also standard methods for calculating square and cube roots of larger integers. And lastly, the third part of his work, Triparty, was concerned mainly with algebra and showed how to manipulate and solve various polynomials. Other famous mathematicians include Christoph Rudolph, who was of Germany. He wrote the first comprehensive German algebra in his work Cos and introduced modern notation for the square root sign. Again, we're seeing more notations being introduced instead of words. We're seeing abbreviations and symbols. So he introduced modern notation for the square root sign. Robert Ricorday of England produced the first English algebra work called The Whetstone of Wit. Incredibly influential, 1557. Relied heavily on German mathematics. Interestingly, introduced modern notation for equal. So there we see where equal originated, which is obviously two parallel lines of equal length. He stated that he used this because no two things can be more equal. So true, Robert. Thank you. Next, Pedro Nunes of Portugal authored the work Libro de Algebra in 1532, focused mainly on abstract problem solving rather than commercial or recreational. And lastly, but definitely not least, because this guy had a huge impact on mathematicians, which we'll see in the 17th century, Francois Vite of France composed in his work known as the Analytic Art, singular, the earliest consciously articulated theory of equations. So we'll take a quick look at 17th century Europe, wrap it up. 17th century Europe, also not a very peaceful time. 95 years of the 100 years in a century were spent fighting major wars. However, there was a major acceleration of mathematical development, and it was a century defined by great intellectual, scientific, artistic, and cultural achievement. They should have worked on their diplomacy a little bit and stopped fighting all these wars all the time. So those wars included the 30 Years' War. Obviously, the Reformation and such had an impact on tensions and whatnot, but we'll dive into the mathematics real quick. In this period, we'll see major fields of mathematics being developed for the first time even, building off of previous mathematics, including calculus, probability theory, and analytical geometry. Major contributions to the theory of equations, as I said, Francois Vite, and and we'll look at a few mathematicians. These include René Descartes. So René Descartes, essential contributor to the foundation of the field of analytic geometry, and he also worked on the theory of equations. Pierre de Fermat, along with Descartes, founded the field of analytical geometry, worked with Pascal on the development of probability theory, and he has plenty of theorems and methods named after him. I like his name. Fermat sounds funny. These methods include Fermat's method of adequality, Fermat's little method, and such. So another mathematician, Albert Gerard, gave the first explicit statement of the fundamental theorem of algebra. And Isaac Barrow and James Gregory. So these two guys around the mid-17th century traveled through France, Italy, and the Netherlands, gathered and organized materials relating to tangents and areas. There was some progress being made and a lot of work being done on what we would refer to today as calculus, like similar problems finding the area inside of or under curves and inside of cones and such. So these were the problems that a lot of mathematicians were working on. James Gregory and Isaac Barrow traveled through all these areas, gathering and organizing all the materials. However, neither could mold these methods into a true computational and problem-solving tool. So they were able to organize them, but they weren't able to apply them generally and form them into a tool for solving problems. So they left that invention to our friend Isaac Newton in the mid-late 1660s. Isaac Newton did a lot of stuff. One of those was inventing calculus, working off of what Isaac Barrow and James Gregory did, and also working off of, there's so much I did not mention. There was just so much taking place. He was also working off of Johannes Kepler in forming his theory of gravity as well. So, or discovery of gravity, I should say. So thank you so much for listening. I hope I was able to communicate that efficiently, and I love you guys.